Okay, seem to have started. Tech rabbit here, yeah. I'm sorry I'm eating a bit of Christmas candy. Quite a lot of it available now. Getting closer to Christmas. Oh, a bit tricky. Yeah, if you remember, we working on this experiment box, and I ran through all the experiments automatically. If you want to catch up on that, you can watch the previous videos. And could actually switch to this one. Now we have a very good set of temperature values with the different experiments. There's various kinds of experiments. It's like 60 minutes, and then how the temperature develops based on what's the effect, and if there's a fan or not. And this data was stored in the database. Now I just visualized it here. I thought I'd go through two things: a little bit how this graph was produced, and then a little bit of commenting on the data itself. I could actually do the data commenting right now. I think this is actually a very good data set, because you could probably expect to see this kind of experimental data collected from any kind of a ad hoc device out in the field. You never get perfect measurement data, and like here we see that we have the heating shunt temperature measurements are very erratic, and then there's some instability in the rest of the measurements also, depending on the accuracy of the temperature measurement method used, and various disturbing factors. But that doesn't really disturb me, because I think this is going to be a very good basis to load into the AI model. That's the basic data. And it will be very interesting to see if the AI model can actually deal with this. My idea with this whole experiment is to actually experiment with, build an AI model that would be, trained with what could be considered a representation of real-world data, which is usually incomplete, erroneous, inaccurate, unstable, and then apply a question test curve to it, and then ask it some questions. So anyway, so the experiment box has basically done its job. It's produced to this extent. I need to still produce a few test data sets, but that I can do separately later. Now I just thought I'd have a few comments on how the data was produced from the database. As you know, we stored the measurement data in the database, and we open it up. I'll comment the more tricks and tips. Now, if you want to access the column names in the database using the name of the column and not the index of the column in the row, then you need to add this comment here. So you need to define a row factory, and this will be SQLite row, and then that enables you to index the row with column names. The other thing is that we're using a bit of SQL here, so select out all the measurements. We only have one table in this database, and then we can order the experiments by experiment first, and then by the timestamp. And then I've made a bit of trickery here to separate out the different temperature measurement data sets, so we get each temperature as an individual curve without any feedback line loops going to the beginning. And that's just the task of this of the loop structure. So if it goes through all the rows and then it's building the sections, and then when it sees that the experiment name changes, then it will reset the values. Also had to clean up the values a little bit at the beginning of the timestamp, because I made an error where I didn't reset the average temperature of the heater block was not reset when a new experiment starts. So I fixed that in the experiment code. And otherwise it's the same graph logic as I've used in the demonstrated in the previous video, so there's nothing new there. So key tricks is to how to select the data from the database, enable accessing columns by name, and then this iteration logic to be able to extract individual temperature curves and display them in the chart. So this is a good basis for moving forward. So yeah. So the next thing will be to use this as base data for loading into the actual model, and that I will make some investigations in a separate video about. So okay, that was just a short update for now. Okay, see everybody later.